Effect of hydroxyl group in phenol. This is today's lesson. In this lesson, we are going to learn resonance structures of phenol, effect of hydroxyl group on benzene ring, and finally, type of reaction of phenol. So, let's begin. First point is resonance structures of phenol and effect of hydroxyl group on benzene ring. Let's see the matter. This is benzene. Here hydroxyl group. One hydrogen is replaced by hydroxyl group. In phenol, there are two moieties, two parts. One is hydroxyl group, another one is phenyl group. Which part is initiator of resonance structures? Hydroxyl group or phenyl group? Let's have a look. Here, this is phenyl group. We know that pi bonding electrons move continuously through pi molecular orbital. Because of the continuous movement of pi electrons through pi molecular orbital, benzene ring achieves electron withdrawing nature. That is, benzene ring attracts electrons from OH, from oxygen. Oxygen has two pair of electrons, and phenyl group is a kind of electron withdrawing group, because in phenyl group pi bonding electrons move continuously. So phenyl group achieves electron withdrawing nature, and for this nature lone pair electrons of oxygen turn into bond pair. When these electrons come here, then electron-electron repulsion occurs. So to diminish this electron-electron repulsion, these pi bonding electrons turn into lone pair electrons here, and as a result we get this compound. Here single bond turns into double bond, oxygen hydrogen. As oxygen donated electron here, positive charge is developed over oxygen, and these pi bonding electrons move towards this carbon. That is why this carbon gets negatively charged. Here double bond, here double bond. So this ortho position gets electronically rich because of the hydroxyl group. Here hydroxyl group shows positive mesomeric effect. Here lone pair of electrons involved. That is why this is mesomeric effect. Mesomeric effect involves lone pair electrons or pi bonding electrons, but inductive effect involves sigma bonded electrons. So here hydroxyl group demonstrates positive mesomeric effect. Because of the positive mesomeric effect of hydroxyl group, ortho position of benzene ring becomes electronically rich. Now these lone pair of electrons turn into bond pair, and similarly, to diminish this electron-electron repulsion, these pi bonded electrons turn into lone pair electrons, and then we get this entity, double bond, oxygen, hydrogen plus. Here double bond, these lone pair electrons turn into pi bond. So here pi bond, this pi bond remains intact, and this carbon gets negatively charged. So this resonance structure in which ortho position becomes electronically rich. Here para position becomes electronically rich. Similarly, this lone pair of electrons turn into bond pair, and to diminish this electron-electron repulsion, these pi bonded electrons turn into lone pair of electrons over this carbon. Now let's see, the compound is like this: oxygen, hydrogen, positive charge here, this is double bond, here double bond is formed, and this ortho carbon gets electronically rich. So this is the resonance structure in which ortho carbon gets electronically rich. In this case, para carbon gets electronically rich. Here another ortho carbon gets electronically rich. Now this lone pair of electrons turn into bond pair, and again this bond pair of electrons turn into lone pair of electrons. So we can write here in this way: double bond becomes single bond, oxygen, hydrogen. This positive charge is vanished because bond pair electrons turn here. That is why this positive charge is vanished. So one pair of electrons, again another pair of electrons, and double bonds are this one, here this one, here this one. Again it happens, repetition occurs, this one, here this happens, and ultimately we will get this resonance hybrid, oxygen and here hydrogen, partially double bond, here partially movement of electrons, and this is negative charge, para carbon gets negative charge, and this ortho carbon gets negatively charged, and this oxygen gets partially positively charged, this carbon partially negatively charged, this carbon partially negatively charged. Similarly, this carbon becomes partially negatively charged. This is resonance hybrid of phenol. Hydroxyl group increases electron density at ortho positions and at para position. That is, hydroxyl group through positive mesomeric effect increases electron density in benzene ring. That is why ortho positions and para position becomes electronically rich. That is, hydroxyl group increases reactivity of phenyl group towards electrophile through increasing electron density in benzene ring. This is the effect of hydroxyl group on benzene ring. That is, it increases electron density in benzene ring, and ultimately reactivity increases towards electrophile. So hydroxyl group is a kind of benzene ring activating group. Here electrophile attacks ortho position and para position because of the presence of hydroxyl group, because hydroxyl group increases electron density at ortho position and at para position. That is why electrophile attacks ortho position and para position, not meta position. So hydroxyl group is a kind of ortho para directing group as well. So hydroxyl group is benzene ring activating group and ortho para directing group towards electrophile. This is all about resonance structures of phenol and effect of hydroxyl group on benzene ring. Let's move on to the next point. Now, type of reaction. Let's look at the matter. Phenol, hydroxyl group increases electron density at ortho position and at para position. When electrophile comes in contact with phenol, then firstly electrophile will attack this ortho position to form ortho substituted phenol. Again, it attacks the para position to form para substituted phenol. That is, two electrophile attacks ortho position of one phenol and para position of another phenol to get ortho substituted phenol and para substituted phenol. Two electrophiles combine with benzene ring. At the same time, from ortho position hydrogen and from para position another hydrogen, two hydrogen atoms go out as electrophiles. That is, electrophilic substitution occurs. The reaction type is phenol undergoes electrophilic substitution reaction, and basically substitution occurs at ortho position and at para position. Because ortho and para positions become electronically rich because of the presence of hydroxyl group through positive mesomeric effect. This is all about effect of hydroxyl group in phenol, benzene ring activating group or ortho para directing group. No more today. Thank you very much.